Hello, it is early in the morning on Sunday, and I am doing some work for Mark Rober's class. Now, I, like you, would much rather be sleeping, but as we all know, Mark Rober is a relentless master who waits on no man. So let's get going. We are doing art with electronics today, and we've got to figure out what we're going to do. And the first thing we're going to do is get rid of that pin. It is angering me by not writing. There we go. That'll be a little easier for everybody to see, including me and you. So we've got to come up with a couple ideas on how to do something creative with, with art and with electronics. And I had a couple of ideas, a simple one and then a much more complex one. And I'm not quite sure which way I'm going to go yet. So let me give you a brief overview, and then I'll do some updates after that. So the first one is the simple one, and that is a Christmas tree. So for this particular Christmas tree, what we would start with is simply a pole with a ton of LEDs on it that maybe some RGB LEDs that we can control and that would produce some light. And just to give some color to this, we would something like this, kind of like the Festivus pole. Maybe this Christmas we can all air our grievances. All right, so we just start with the pole with LEDs, and that would be the electronic engineering part, making sure those things turn on and off when you want. And to keep it from tipping over, we would have a base. And coming down from that base would be an absolute ton of fishing line. So to keep this thing from tilting or turning over, you'd have to go up one side and then down the other. And you'd have to find some way to get it to stick there. I was thinking about maybe running Velcro all the way around to keep the ones down here on the bottom from shifting. Up here we could just use a nail to wrap everything around, or even an eye bolt, or who knows. But I was thinking about maybe doing Velcro down at the bottom. I just don't know if that would be strong enough. I might have to go to the trouble of putting in a series of saw cuts around the perimeter, or putting nails in. I don't know. It doesn't really matter to me at this point. We just have to kind of experiment and see. But then you would have all of these. Uh-oh, we've got another pin that's angering me. Yeah, it's that kind of morning, I guess. But you would have all of these fishing lines, and the idea would be use that monofilament line, right? Okay, I guess I should clarify, not just any line, but clear monofilament line. And the general idea is to create something of a diffraction grating so that you have lights streaming, around. You would need a lot of line, though, to make this work. It would take a while, but it would be simple to do, and there should be a relatively high probability of success. For those of you that don't know what diffraction grating is, I've pulled some out of a monitor in a teardown I did recently, and it looks kind of like this. And as you can tell, it causes things to spread out and distort, right? So we would be doing that with the light. It would give it, it's not really a holographic effect, but that's probably how people would describe it. Kind of cool, huh? That's not fancy graphics. This is diffraction grating. So that would be the idea. So we get a pole, we wrap a cone of monofilament line around, and we go from there. So that's idea number one. And idea number one is highly achievable. Oh, Chester says hi. This is the shop cat coming to visit. He's a good boy. Second idea is a perpetual pendulum. I know this might be more a science experiment than art. But with our perpetual pendulum, we would still start with a base. Guess we're doing round things today. You know, and have these things all come up to some platform at the top where we would hang this thing down. And, you know, there'd be some mass down here. And what we would want to do is keep this mass swinging back and forth continually. Well, due to, what is it with pins this morning? To keep this thing going, we would have to find some way to drive it. Otherwise, air resistance would cause it to slow down and eventually stop, or even energetic losses in whatever line we use. I mean, I imagine the best thing to do is a rigid arm, you know, like some 2mm rod or something like that, you know, stainless steel. I don't know about that yet. Probably what I would want to do is just use some like braided Dacron or something. But anyways, we would need a way to keep that going, and we would need something to make it art. So what I was thinking we could do is, you know, instead of just having a circle base, we would make a hemispherical base. Well, not really a true hemisphere. We would just take a section of a sphere and fill it with sand. So as this pendulum goes through, it drags through and it creates patterns. You know, whatever that pattern would be, I don't know. Except that this would slow down over time much, much more rapidly than just a pendulum swinging through air. So you would really have to drive it. And probably the way that I would do that is, and I'll do this in another paper here in a second, but make this a magnet and put a coil of copper wire, hide it underneath the sand, and then as this thing swings, we can use the copper wire to energize, create a magnetic field that sucks this pendulum towards the center, and then we'll release it when it gets near the midpoint, and then, you know, let it fly around. So it'd be a little hidden. I don't know what the purpose of that would be. I don't know what the purpose of either of those are, but I guess that's just the purpose of art, just to kind of give you something to think about and hopefully make you, in some cases, feel happy, although not all art is happy. All right, so let's take a look at that. So the Christmas tree idea is easy. It's simple. I don't know that we need to explain that any further at this time. All right, we would need a way to stabilize the top platform. I guess it could come to a point, but I have an idea on that in just a second. Anyways, let's get to the electronics because that is why we're here. Then I'll talk about the mechanical aspects here in a second. So we would have to find a way to make that spherical section. And then we would get a strong magnet, maybe something, I forget magnet grades in 42 and 52, something like that. And I didn't even draw it to the center. Look at me, I'm a mess. We'll just hide all of that. There we go. All right, so there's our magnet. I'll probably have to encase it in something just because these magnets are pretty brittle. So let's assume I get a piece of brass or copper that this will slip into. Now, this magnet is going to have axial magnetic field. What that means is that field lines, which a lot of our viewers here aren't going to know what those are. If you've ever seen a picture of somebody touching a giant metal sphere and their hair standing up on end, something like that. But the field lines are imaginary, by the way. They don't actually exist, but it's a physics concept. It's a little more advanced than probably some of the users in this class are aware of. But anyways, this magnet has these things called field lines that don't really exist. We just kind of imagine that they're there. And if you run another coil of copper and you run current through it, the field lines from this magnet will interact with the field lines from the copper wire. And you can actually use it to suck this magnet towards the center of this magnet. If you've ever played with magnets, when and I'm sure a lot of people have, there's that sometimes they push apart and sometimes they suck together. Well, that's what we would be doing here. We would be taking advantage of the suck together part. Permanent magnets are just that. They're permanent. There's nothing you can do. But electromagnets made out of copper wire, you can turn those on and off at will. So if this thing is swinging up and away, you want that force to be non-existent. You want this thing to be able to swing up and away freely. But then when it returns, right, that's what you want that magnet on, so that you get a huge force pulling it towards the center. Okay, that'll really get this thing going. And, ooh, I have an idea. Okay, now, if you run electrons through that lower wire in the opposite direction, you can create repulsion, which I said is not what we want. And it's not. But it raises two use cases for that. The first one, we could create something that that attracts, and in the other one, we could drive it through repulsion. And I'll tell you why I think that's interesting here in just a second. If you drive it through attraction, we could create something called a Foucault, I don't know how you pronounce it. A Foucault pendulum. And if we drive it through pushing, we can create a random pendulum. That would be interesting. Okay, so in the first case, we're going to have, we'll have to come up with a sensor here too. An input and an output. So in the first case, we wait until the pendulum is on the downswing and we suck it into it. And what should happen is that it gives it an energy boost in the direction of travel, and that'll give it more energy to swing, and it'll swing in the direction that it was swinging before. And that's interesting for a reason. The other use case, we are going to wait till it's in the middle and we are going to give it a push out. So this is a pull in. It's predictable. This is a push out, and it's going to be random. Now, what that'll look like over the course of a day on the pull in is that this thing mostly travels in straight lines over and over and over again, right, back and forth. But on the one that pushes out, it's going to start doing some elliptical things, and that should give us randomness in the path of travel. This is just approximate, right? The other cool thing about Foucault pendulums, and by the way, I don't know that I'm pronouncing that right. I don't speak French. Sorry, guys. Is that thing, if you were able to remove all other forces that you didn't want to deal with, that thing would swing in that plane indefinitely, even as the Earth rotated. So if we do another image here, this is maybe a top down from the North Pole or something, I don't know. And our pendulum is going to swing in that direction as the Earth spins around. It'll be decoupled from the influences of the Earth, and it'll spin. Would that be Coriolis? I don't know. I'll have to read on that. But anyways, it'll spin in the same plane throughout the day as the Earth rotates around. So what that'll look like to us is that it's actually pivoting in place. You could theoretically, although I doubt practically, I mean, because to get this to work, you would even have to remove air currents. But you could theoretically create a clock so as this pendulum spins, it would stay in the same orientation as the Earth spun underneath it. I don't know that I got this orientation right, but anyways, you could theoretically create a clock, a very slow-moving clock, as long as you reintroduce the energy. But pendulums tend to go elliptical. They don't like spinning they don't like going in straight lines. Too many forces come in. You would have to kill those, and there's a way to do it, I remember from college, and it is not chariot. Is it a Charon ring? I don't know. I don't know if that's right. It's been too many years. I always liked Foucault. I've seen these in museums a couple times. Only reason that I know anything about them at all, I'm not making this up. I've seen these in a couple natural science museums. They're really cool. They have one at Griffith Observatory. Saw one out in North Carolina. I think the first one I saw was out in North Carolina years and years and years ago, and it was like 3 stories tall, and it was just fantastic. It was knocking over these domino-shaped things to indicate time. It was fantastic. Anyways, if I remember correctly, what you do is on the outside of this, you put a conductor. It could be anything, aluminum, copper, whatever you got. I would probably use some sheet copper I've got out in the garage, or maybe even a copper pipe would work. I don't know. But you're taking advantage of this thing called eddy currents. And as this thing swings back and forth, when it approaches the, we'll just assume this is our copper ring or copper whatever for now. As this thing swings in, the lines of flux intercept the conductor. And nature's got a thing about inertia. It likes to keep things the way that they are. And what it'll do is, as this thing approaches, is it'll create this thing called an eddy current that will slow down the pendulum bob. Well, that's fine as we approach the end of a swing. We want it to slow down because it's going to return and come back. It's not going to have much speed at all. And you need speed for this effect to happen. Anyhow, what that should be able to do is provide damping to keep the side-to-side motion. So this pendulum, instead of swinging in an ellipse, it should start swinging mostly in a straight line. Now, do we have to take that off to do this? Because really what it'll do is cause it to, it'll shoot off in a straight line, or it'll shoot off with some elliptical energy, and then it'll return in a straight line. Oh man, this is going to be a lot of work. All right. So let's start tackling things. How would we suspend it? How would we detect? How would we drive? All right, let's do the mechanical first. Where am I going to get a large spherical section to act as the base? You'll have to excuse me for one moment. Well, no. We can finish this up. We've got a cat that needs something here. Okay, we could heat and bend plexi. I don't know how yet. We could heat it up and just let it naturally curve, I guess. We could heat it up in a, capture it between two pieces of plywood, one with a giant hole in it. Heat it up and put air in between the two pieces of plywood. That would cause it to bow, but that would probably be more parabolic than spherical. We could route it. Basically come up with a jig that allows a router to pivot in 2 dimensions and just, swing that back and forth and start carving out some wood. That would work. We could use a lathe. I've got a metal lathe that doesn't have the ability to, you need a radius cutter, but I don't have anything as big as I'd want. I also have a wood lathe. We could just, do it by hand. It doesn't have to be all that accurate. Within a millimeter or so, it's certainly achievable on a wood lathe if you've got a template. That'd be fast, easy, successful. The only trouble is wood's ridiculously expensive right now. But I've got some out in the garage. Maybe we could find a suitable piece. Okay, so now we need to put in some supports. How are we going to do that? Oh, our friend Chester is back. He says hi to all the people out there in TV land. Okay. Oops. Oh no, I'm moving all over the place here. There we go. So how do we connect those two? There's this let's see, maybe right about there, maybe right about there, maybe right about there. They have these hexapodal actuators, and that's not the right name, but I can't think of the name right now, that they use for motion control. And basically, you run two rods to. This is a top-down view, by the way. From the side, it would probably be a little more abstract. I don't know if drawing it would even make sense. Probably look like something from space. It would certainly look like something from engineering. Anyhow, you run 6 rods. You basically have 3 anchor points on each object, and you cross anchor points. And that gives a very stable platform that's highly adjustable, highly stable. And we could probably get online and find some, maybe some drive shafts, universal joints to couple them. That might be useful. All right, so you've got this pendulum, and it is swinging back and forth through center, and it's going to have a magnet on it. It's going to have a magnet on it. Well, like, at least that's the way I'm going to think about driving this thing. It's going to have a tip on it. I don't know what we're going to do yet. Anyhow, as this thing swings back and forth, we're going to have a coil in the middle that attracts and typically, I think the way that these are done is that you do a secondary coil further out. And that secondary coil is the sense coil. So as the magnet passes through, it says, okay, trigger, and off you go. But I wonder if you even need that. I wonder if you can't just do it with one. It would depend on how much energy we're losing on each swing, but why can't you use the same coil to both sense and drive? Not at the same time, mind you. Well, maybe even at the same time. When you feel the magnet getting close, just pulse it and off it goes. If not, the period of a pendulum is highly predictable, at least for the small angle approximation. If you're wondering how I know these things off the top of my head, I'm no genius. I taught physics for 15 years. Well, 14 years. Physics for 14 years. And this is all part and parcel of it. I just dig this stuff. So 2 pi root L over G is approximately proportional to the period. And you can drill down from that. You can get more accurate if you're swinging out more than like 15 degrees. You start having to do some corrections, but that's pretty close. Anyways, the period is not dependent on how far it swings. The period is dependent on how long this is. And it's going to be the same for each and every swing. It's going to be very predictable, except for the sand. That does add a degree of difficulty to the mess. But anyways, what else would we need? Anyways, as this magnet passes through our coil, we would sense it, and then on the return path, we would know when it's coming, and we would be able to smack it and drive it and do whatever we're going to do. So either sucking it in for the Foucault state or knocking it out for the chaotic state. I don't know. I like that, but man, that's a lot of work. It's a lot of work. We would need magnets, some fancy sand. We would need some U-joints. We would need that base. Copper and electronics. Versus the other one where we just need LEDs and fishing wire. I don't know. Don't know. It's probably 25 to 40 hours of work by the time you're done with the wood turning and the... Well, not that much, actually. I think I'm overestimating things. Depends on how I make this. That's going to be time consuming. And then figuring out the electronic drive mechanism is going to be a little time consuming. Maybe it's not that much. Maybe it's like 15 to 20. I don't know. It's going to be time consuming, but it's a sure win. I'll have to give it some thought. And with that, I am going to go see what Mr. Chester the shop cat needs and think on this some more. Thanks so much, and we'll see you at the next stop in this design process.